So as Martin mentioned, what we're going to be covering, Bill and I, is the Marginal Ice Zone Observations and Process Experiment. One thing I want to clarify right off the bat is that if you take a look at the project duration there, it started September 2011, ended last August 2013, and our field deployment was July and August 2013. So you can imagine that we concentrated with this project, as I think NASA intended, was a science-driven effort to really push the boundaries of what can be done or what can be learned with unmanned aircraft systems and instrumentation in the Arctic. So really the first 2 years, it was originally designed as a one-year project, then NASA changed it to 2 years. So the 2 years were really spent getting the systems together, doing the field deployment, and the science that I'm going to go over here is the results that came out of the one-year extension that we had on the project, and Bill Emery had taken over as PI on the project when I retired last summer. So what I'll do is I'll start off with some motivation and goals, talk about, not spend too much time on the UAS themselves and instrumentation as Martin requested. And I'll go over some of the preliminary science results. And in bullet 4, I have that grayed out there. That was the operational technology results, the lessons learned, which are really the big outcome of this project to date, and I sent out a document that lists those. There's a number of pages that cover that, and that would be useful material for the follow-on effort or follow-on talk that Martin mentioned. You see we're supported by NASA, with support again by NOAA as well, and that's our project website there. Any questions, feel free to interrupt me if you have questions during the talk. Otherwise, hopefully I'll have left a little time at the end to get back to some questions. Okay. Slide number 2, again, is the MIZOPEX participants. There were quite a few, over 30 lead investigators and individuals involved, 15 different organizations. You see the list there. Really, a lot of those were instrument PIs who were focusing on specific instruments that we were then integrating into the UAS, and then also the UAS operators, and then some science personnel as well. I just want to make a special thanks to the NASA Sierra group, who kind of at the last minute stepped in to pull this project together in terms of the UAS. We originally started out, the project was designed to use the Sierra, which we'd used in the Arctic before, flying out of Svalbard. We then switched gears to the NASA Icana for a variety of reasons, and then we had to go back to the Sierra kind of at the last minute. So they did a great job getting their systems together and getting into the field. And then certainly Alaska Fairbanks, their Scan Eagle group really was stepped up, did a lot, as you'll see, and special thanks to them. And again, we have the individual team listed at the website if people would like to check out who did specifically what with what instruments. And I'm just going to check now, make sure everybody can still hear me, since I can't see anybody, obviously. Hopefully this is still working.
Yes.
Okay, great. Now on to slide 3. Background, again, MIZOPEX, from my interpretation of the NASA announcement, was a project intended to figure out how you can best make use of unmanned aircraft systems and get them operating in the national airspace in the Arctic. And there's a lot of challenges in both of those big bullets that I've got there. So what we did is we came up with a science wrapper for this, a real science driver, which was processes in the marginal ice zone, particularly during summer melt, that we thought would really create a lot of challenges for the UAS themselves, and NASA required that the project use at least 2 UAS, one of which would be a NASA UAS system, but would also really push the boundaries of what we'd already done. We'd flown UAS in the Arctic before. There was in the Antarctic. We know we can do this. So what we wanted was a project that really took advantage of what UAS could do and really showed, or would try to show, where you might take UAS versus manned aircraft or field crews to do a project. So again, the science, well, I'll get a little more into that next slide, but we really wanted to create these multiple challenges. And you'll see there at the last bullet, we ended up using 3 different UAS, which was 3 different crews, which made it, you can imagine, more complicated. a lot of sensors and a lot of systems. So the idea was to not just go out and measure one particular parameter or a single one or two parameters, but try to measure as many as we could to get a detailed understanding of what we were seeing and what the ocean conditions and the atmospheric conditions to a lesser degree were at the time. We were focusing primarily on the surface conditions. The national and international airspace operations, this just, you can talk about this for hours. These challenges beyond line of sight flying wasn't allowed before. Airdrop sensors were not something that FAA had dealt with. All these things are things that I think lend themselves to the future talk that Martin mentioned. So I'm going to skip over those. A little more on the science. What I've got there in the 4 panels with the red landmass is a representation of the sea ice age